Okay, so today we're doing 7.3 double and half angle identities. We will now deal with some other identities that follow naturally from the addition and subtraction identities. So now you can see what we're doing. We're not going to do all the examples in the notes on this video or these videos that I make today. I'm going to save a couple at the end for class tomorrow and Tuesday. So hopefully everybody is well and back and ready for class. Okay, so we have some formulas and more formulas. They're on that yellow sheet that I passed out. The formula for sine is sine 2x equals 2 sine x cosine x. Cosine 2x, so it's a double angle. It has three different formulas, and you're going to use whichever one works the best for your situation at the time. So it's cosine squared minus sine squared, 1 minus 2 sine squared, or 2 cosine squared minus 1. And then the formula for tangent is tangent 2x equals 2 tangent x over 1 minus tangent squared x. So these identities are very easy to prove using addition and subtraction. So we'll just prove the sine 2x equals 2 sine x cosine x, and then if you can probably figure out how to do the other proofs as well. So remember, when we do a verification or a proof, you start with one side. So I'm going to start with sine 2x. That is going to equal sine of x plus x, right? X plus x is 2x. So now on our addition ones, we have, this is one of them that we're going to add, and this is the other one that we're going to add, right? So even though they're both x, when we do our addition formula, we're going to use those. So our addition formula is going to be sine x cosine x plus cosine x sine x. So this is that green x, and then this is the green x right here, and then these are the red ones. So even though they're both x's, they're on there. Okay, so you have sine x cosine x plus, and then since a multiplication is commutative, you could write this as sine x cosine x. And then sine x cosine x plus sine x cosine x equals 2 sine x cosine x. So we have proven that sine 2x equals 2 sine x cosine x. So that's one of the formulas. Okay, we can use these formulas to evaluate given different pieces of information. So we're trying to evaluate cosine 2b. So you choose whichever cosine formula you want to choose. I'm going to use cosine 2 beta equals cosine squared beta minus sine squared beta. Again, it doesn't matter which one you use. Most of the time, you're going to use just whichever one works for your situation. So I need to figure out what cosine squared beta is and sine squared beta is. I know that tangent, so I'm going to come over here and draw a triangle, because if you know ratio, you want to have a triangle for it. Tangent is negative. Okay, so if tangent's negative, we're not in this quadrant, and we're not in this quadrant, right? And then sine is positive, so we must be in the second quadrant, because sine is positive. Ooh, positive in the second quadrant. Let's try that line again. Okay. Tangent is opposite, which is 5, over adjacent, which is 2. One of those has to be negative. Since we're in the second quadrant, your x value is going to be negative. And then we need to find the hypotenuse so that we can do the sine. So you have negative 2 squared plus 5 squared equals c squared. 4 plus 25 equals c squared. 29 equals c squared. So c is going to be plus or minus the square root of 29. Hypotenuse is always positive, so this is going to be the square root of 29. So we need to find cosine squared and sine squared. So cosine of that triangle is negative 2 over the square root of 29. I want to square it. Minus sine is 5 over the square root of 29. And we're going to square it. So that gives me 4 over 29 minus 25 over 29, which is negative 21 over 29. And that is your answer for that one. All right, so next page. Same idea. We have evaluate the tangent of 2 times the arcsine of negative 2/3. So the arcsine of negative 2/3, this right here is an angle, right? When you do that arcsine of a ratio gives you an angle. So this part right here is an angle. So we're trying to evaluate the tangent of 2 times some angle. We have a formula for that, right? So the tangent of 2 theta is 2 times the tangent of theta over 1 minus the tangent squared of theta. So that's a formula on the previous page. So again, we have a ratio. We don't know what that angle is, but we're trying to find the tangent. So we need to draw a triangle. It says the arcsine is negative 2/3. So arcsine can either be in the first or the fourth quadrant. If it's negative, it needs to be in the fourth quadrant. So sine is opposite, so negative 2 over hypotenuse. We need to find the tangent. So if you need to find the tangent, then you need to find the adjacent side. So you have a squared plus 4 equals 9. A squared equals 5. A equals plus or minus square root of 5. We're in the fourth quadrant. Our x value is positive, so we're going to use the positive square root of 5 for that one. So tangent, I'm just going to write it again so that we remember it. Tangent of 2 theta equals 2 times the tangent of theta. So the tangent of, here's our theta, right, in that triangle. Our tangent is negative 2 over root 5. So 2 times negative 2 over root 5 over 1 minus the tangent squared. So negative 2 over root 5 squared. Simplify and rationalize the denominator. Okay, so we have negative 4 over root 5 over 1 minus 4/5, right? So that gives us negative 4 over root 5 over 1 minus 4/5 is 1/5. So the whole thing over 1/5. Let's come up here. Negative 4 over root 5 times 5 over 1, which gives me negative 20 over root 5, and we need to rationalize because it tells us to. So that gives you negative 20 root 5 over 5, which is negative 4 root 5. So a good rule of thumb when you need to rationalize or when you should rationalize, if you have right here this, oops, that was supposed to be a highlighter. Let's fix that, 20. Let's try again. Okay, if you have, if you have a common number in 20 and this root 5 right here, if you have common numbers right there, then you should really rationalize it because you can reduce that fraction. So that's kind of a good rule of thumb to look at. Okay, the next one we're going to do a verification. Sine 3x over sine x cosine x is for cosine x minus secant x. So I'm going to start with the left side on this verification. Let's go to green. So I have sine 3x over sine x cosine x equals. Sine 3x I can rewrite as sine of 2x plus x over sine x cosine x. So now I can use my sine plus formula, the addition formula, right? So that's sine 2x cosine x plus cosine 2x sine x all over sine x cosine x. Now, you can't just factor out a sine x or a cosine x because this 2x right here goes together and this 2x right here goes together. So we need to apply the double angle formula or make that a sine x plus x and do that again. I think it would be easier to do the double angle formulas for each of those. So for sine 2x, the double angle formula is 2 sine x cosine x. So that's this right here, equals 2 sine x cosine x, and then it's being multiplied by another cosine x. Plus, now cosine 2x, we have choices on what formula to use. So just pick one and kind of go with it and see if it works. So I'm going to go with the cosine squared minus sine squared. And then again, I'm just choosing one of the formulas. That's the one I remember the easiest, so I'm going to use that one. So I have, this is cosine squared minus sine squared times sine x all over sine x cosine x. So I have two terms, right? Let's get these in a different color. I have one term right here and one term right here. They both have, they both have a cosine squared and all that, but they both have a sine x in common, and I have a sine x in the denominator. So I can factor that sine x out of the numerator, and I'm left with 2 cosine squared x, right? This is cosine squared, plus cosine squared x minus sine squared x. Now I don't need that parentheses around the cosine squared minus sine squared anymore because I've taken out the thing that's being multiplied. I don't want to distribute it in because I'm trying to get rid of this sine x on the denominator, right? So we're going to cheat. Let's look at what we're trying to equal, right? We don't have a cosine or a sine on the denominator. We don't have a denominator. Actually, we're going to have a cosine on the denominator with that secant, but we don't want to have the sine in the denominator. So I factored it out, put it all over sine x cosine x. Now those are factors, they can cancel. So I have 2 cosine squared x plus cosine squared x. So that's 3 cosine squared x. I think I'm supposed to have 4. Oh, not yet. Okay, so I have 3 cosine squared x minus sine squared x all over cosine x. Now, like I had just said, I think I'm supposed to have 4 of them. If you look at our answer up here, it has 4 cosine x. So I'm going to need 4 cosine squared x's to cancel off with that. So I can rewrite sine squared as a cosine, right? I have this formula, sine squared plus cosine squared equals 1. Oh, I just have a couple more minutes. So sine squared is going to equal 1 minus cosine squared x. So why don't I replace this sine squared with 1 minus cosine squared so that I have another one. So I have 3 cosine squared x minus 1 minus cosine squared x all over cosine, which gives me 3 cosine squared x minus 1 plus cosine squared x all over cosine, which is 4 cosine squared x minus 1 over cosine x. We're running out of time in room, which gives me 4 cosine squared x over cosine x minus 1 over cosine x, which gives us what we're looking for. The cosines will cancel. You get 4 cosine x minus secant x, and that's what we're trying to prove. Sorry that got so little at the end. Okay, I'm going to cut this video off and then do another one for our next pages.